so much. We hope that this is truly helpful for you because this is the main goal of the Pump Up project. So I'm so happy to have you with us today. And I hope you enjoy. Of course, you can ask questions at the end of the session, and you can join all of the other sessions, and of course, use the educational outputs of the project. And we're here to assist you in case you need any help or guidance. The whole team is always there to support you. So I think at the moment that we are ready to start.
Yeah.
Today the session is again hosted by Innovella, but the sessions will be held by our UPV partners, the Polytechnical School of Valencia, who is the lead partner of the project, and they are also among the experts who developed the courses and all of the educational outputs of the Pump Up project. So I think that today Mercedes Romero is the one that's giving the session, if I'm not wrong.
Hello, I'm giving the session.
You're in the session today.
Yes.
Sorry, Clara, I think she said that you're hosting on Monday, but okay, now I have it. So whenever you're ready to start, we're here to enjoy your little introduction to Module 2 of the Pump Up course.
Okay, thank you, Irini. Hello, everyone. Welcome to the second session of the seminar. I'm Irene Martinez. I am a researcher at the Polytechnic University of Valencia, and it's a pleasure to be here with you. This seminar is organized within the framework of the Erasmus Plus Pump Up project, and is the second session of the online training course. The aim of these seminars is to share the main results of the project and support trainers, professionals, and educational centers in using these materials and spreading the knowledge. Thank you very much for joining us today, and we hope you find this session useful and interesting. So last Monday, we built our theoretical foundation about heat pumps in Module 1. We understood what heat pumps are, how the cycle works, what types of heat pumps exist, and the principles that guide selection and design. Today, we are reviewing Module 2 of the course, which is focused on the comprehensive evaluation of the building, the client, and the site conditions. Additionally, this session will help us understand how this content can be delivered to learners in a clear, practical, and accessible way. So I'm going to share the screen now. Okay. So Module 2 addresses a critical preparatory phase that occurs before any heat pump system is installed, assessing site conditions and building long-lasting relationships with the customer. As you can see, it's structured into 3 different lessons. Lesson 1, Client Expectations Management. Lesson 2, Site Examination and Preparatory Work. And Lesson 3, Site-Specific Heat Loss, Radiator Energy Output, and Hot Water Requirements calculations. After these lessons, the course includes a questions and answers section, a self-assessment quiz, and practical exercises. These parts are very useful for checking understanding and encouraging learners to apply concepts in realistic situations. So now let's begin with Lesson 1. The first section, Client Expectations Management, establishes the professional and interpersonal framework for heat pump projects. It emphasizes that successful projects begin with effective customer communication and managing their concerns, possible misconceptions, or unrealistic expectations about energy savings. It's important to communicate to learners that the success of a heat pump installation depends as much on communication as it does on engineering. To this end, key aspects are clarity, transparency, and personalized guidance, as well as comprehensive communication, which can significantly enhance overall client satisfaction. An example would be educating clients about heat pump operation, instead of using technical vocabulary describing the thermal principles of the system, it would be more useful to explain that heat pumps work by transferring heat instead of generating it. This way, clients understand the fundamental concepts and the installer becomes a trusted advisor. Now, let's walk through the customer journey and best practices associated with it. The first step is initial inquiry and consultation. It's important to schedule a comprehensive consultation with the client. This is a key opportunity to build trust. Installers should listen carefully to their needs, assess their property details, and explain the broader benefits of heat pumps against traditional heating systems. After this first contact, clients should view their investment as part of a larger sustainability project, and the installer-customer relationship should be set into a valuable partnership. Next comes the site survey. This is the technical evaluation of the property, which we will see in more detail in the next section. But from a professional relationship perspective, it's important to communicate what we're doing and why we are doing it. And then, based on this survey, it's time to build a comprehensive proposal covering heat pump options, cost, projected installation timelines, and estimated energy savings. Also, you need to include potential challenges or necessary upgrades, as an honest proposal builds more trust than an overly optimistic one that creates expectations that end up not being met. Next, it's time to select the right heat pump, balancing multiple factors, including potential energy savings, cost-benefit analysis, and individual customer preferences. And again, presenting them in a simple way. This helps bridge the gap between technical data and the client's informed decision-making, ensuring that they feel confident in their system and that the system delivers the best value for their specific needs and lifestyle. The next step includes navigating available incentive programs to make it more financially accessible and attractive to a broader range of clients. This includes staying up to date to grants at both the local and European level. And then about regulatory compliance, it's crucial to coordinate with the distribution network operator for electrical grid compatibility. Learners should be prepared to navigate through a broad landscape of standards and certifications to ensure the system is not only legally compliant, but also safe, efficient, and ready for long-term operational stability. Now that we have cleared the previous steps, the installation process begins with the preparation of the site, including both logistical arrangements and administrative tasks. At this stage, a clear preparation demonstrates technical competence and fosters clients' confidence by showcasing a smooth and professional workflow. This stage also includes testing the system for optimal operation, conducting performance benchmarking under different load conditions to verify that the flow rates and temperatures align with the original design specifications. Lastly, it's crucial to maintain post-installation follow-up to build long-lasting and long-term customer relationships. This follow-up is what turns a one-time client into a long-term advocate who may generate future business opportunities. Additionally, maintenance tips and expert ongoing advice are some of the ways to validate the client's investment decision. So,
excuse me, Mercedes.
A nuestra gente, a todo el mundo y hasta el día de hoy no ha podido ser, una pena, agradecer a toda nuestra gente por venir, por apoyarnos desde sus casas.
I managed to mute, so please continue.
Okay, thank you. So to put it all together, After this lesson, learners should be able to complete the following points. First, describe the complete customer journey for heat pump installations, from initial inquiry to post-installation follow-up. Then, they should also know the importance of using clear, non-technical language when communicating with clients, translating complex thermodynamic principles and efficiency ratings into relatable benefits such as comfort, reliability, and cost effectiveness. And also elaborate an effective proposal, including tailored heat pump options, cost breakdowns, realistic project timelines, energy saving projections, and environmental benefits. All this to facilitate informed decision making. So now we can move on to lesson 2, site examination and preparatory work. This lesson covers the physical and technical evaluation of the property. First, we start with choosing the right location for the heat pump. The outdoor unit is the visible and audible part of the installation, so its location is critical. There are several factors to consider simultaneously. First of all, noise. All heat pumps produce some operational noise, which can be bothering if the unit is placed directly below a bedroom window or close to a neighbor's property. So it's important to discuss the noise aspect before deciding on placement. Another relevant factor would be wind and weather protection. Where possible, it's preferable to choose a position sheltered from strong winds. And also the air discharge should not be oriented towards a wall or towards the main wind direction. And also orientation. For maximum efficiency, it's recommended to place the heat pump on the warmer side of the property, ideally south-facing. This ensures the unit has access to the warmest ambient air, improving the coefficient of performance of the heat pump. Another important aspect to consider is the accessibility. In the chosen location, the unit must be accessible for maintenance. Once we have the location chosen, we need the base, which must be a firm, flat, level surface capable of supporting its weight and minimizing vibration transmission, which can also contribute to noise. Along the same line, proper clearance is essential to ensure optimal airflow and long-term performance. As we stated earlier, it also helps making the unit fully accessible for maintenance. This reduces the risk of system overheating and allows technicians enough space to perform routine inspections or component replacements without unnecessary obstruction. We also need to assess the existing electrical system to confirm its suitability and inform the distribution network operator if it's necessary. And then, of course, sizing the heat pump for the client's needs and planning a proper design. It's important that the full layout of the system is understood before the installation of any component begins. And now, on the more technical side, some best practices include, first, flushing the water system thoroughly, especially if the heat pump is being installed on an existing system. This is done in order to avoid and to remove accumulated debris that could otherwise clog the heat exchanger and significantly reduce the operational efficiency of the new unit. We should also ensure clear drainage of condensation, preventing ice buildup or water damage around the external unit. We should also need to make the water connections tight and secure, insulating all pipework to minimize heat loss. This ensures that the energy generated by the heat pump is delivered effectively to the heat emitters rather than escaping into unheated spaces. And it's also crucial to conduct a Legionella risk assessment and set up appropriate protection. Temperatures of at least 60 degrees Celsius are needed to eliminate any bacterial growth within the storage cylinder. All these actions should be made by a competent person following manufacturer instructions and with the adequate certification, as is the case for refrigerants, which need to be handled by personnel with the relevant EFTA certification. So after studying this lesson, the key learning outcomes for learners are listing the key factors in selecting the optimal location for an outdoor heat pump unit, noise, wind protection, orientation, among others. Specify the requirements for a suitable installation base, firm, flat surface. Describe the process for assessing the existing electrical system and the distribution network operator notification requirements. Explain the procedures for system flushing, thermal fluid filling, and Legionella risk assessment during installation. And finally, understand that refrigerant work must be only performed by qualified personnel. Finally, we can move on to lesson 3, site-specific heat loss, radiator energy output, and hot water requirements calculations. This lesson focuses on 3 different sections, and the first one is the mathematical hertz of the site assessment. Everything else, the heat pump capacity, the meter sizes, the pipe dimensions, flows from the following calculations. And as trainers, these sections should be explained in detail. So starting with heat loss calculations, the total heat loss of a building has 2 components, fabric losses and ventilation losses. Fabric heat loss is the heat that escapes through the physical structure, through walls, through the roof, windows, doors, and floor. And this is calculated in this first term of the equation, where A is the area of each building element, U is a specific value that measures how much heat passes through per square meter per degree of temperature difference, and multiply by the temperature difference between indoors and outdoors. And then in the second term of the equation, we have ventilation heat loss, which accounts for heat carried away by air exchange through gaps, extraction fans, and also deliberate ventilation. This is calculated as the volume of the room multiplied by the air exchange rate, which is how many times per hour the air is replaced, also by the volumetric capacity of the air, and again for the temperature difference between indoors and outdoors. And then, well, the total heat loss is the sum of both terms in this equation, and this calculation must be performed room by room and then aggregate for the whole building. In order to facilitate this process, there are website tools that provide heat loss calculators, and this is one of them, Microgeneration Certification Scheme. And it's very useful because it also has reference tables for example, U values. Now that we have heat loss calculated, we can move on to sizing heat emitters. We're going to explore 3 different types: radiators, fan convectors, and underfloor heating. Starting with radiators, the critical concept is the oversize factor. Standard radiator catalogs rate output at a mean water-to-air temperature difference of 50 degrees, which corresponds to a boiler system running at about 70 degrees Celsius. And with heat pumps, if they run at approximately 45 degrees Celsius, the actual temperature difference is much smaller, and the radiator's real output is significantly reduced. Because of this, the oversize factor tells you how much bigger the radiator needs to be, depending on the heat pump's flow temperature and the system design. On the other hand, fan convectors offer an interesting alternative where wall space is limited. They use a fan to force air across heat transfer fins, delivering high output for the compact size. We need to note that these devices will need a small electrical power connection in order to operate the fan. And then we also have underfloor heating, which is ideal for heat pumps. This system has a series of pipework loops that are embedded into the floor. Because the floor surface area is so large, it can deliver sufficient heat even at very low flow temperatures, and its even heat distribution reduces stratification and improves comfort. Additionally, underfloor heating should also be designed to operate at the lowest possible temperature to achieve the desired demand output. And this final section concerns domestic hot water. Currently, there is no definitive consensus on the optimal sizing methodology. Contemporary systems have an automated mode switching mechanism alternating between space heating and domestic hot water production. Others prioritize the water until the tank is full in order to avoid triggering the electrical backup heater, which significantly reduces the overall system efficiency. Learners should be aware that there's also a shift in the latest trends, as in modern, highly insulated homes, the domestic hot water demand is often the main load, and can sometimes even exceed the space heating requirements. So, as for best practices for installers to properly size the system and that learners should have understood, it is advised to follow norm standards and regional regulations, which provide validated calculations to ensure the heat pump is neither oversized, leading to inefficiencies, nor undersized, leading to comfort issues. They should also conduct a detailed study of the client's actual water usage, accounting for the number of occupants, the simultaneous use of multiple outlets, and specific habits to determine the appropriate cylinder capacity. But this last part is further explored with the practical exercises. So to summarize this last lesson, the knowledge objectives for learners are the following points. Calculating total heat loss in a room and building through the provided equation and understand the values associated with it. Also, compare different heat emitter types, their suitability in different scenarios and their advantages, and assessing hot water demand needs in modern highly insulated homes. So now we have gone over the more theoretical part of the module. Now let's dive into some of the practical questions and exercises to see how these concepts are applied. The course includes a questions and answers section, and this part is very useful because it addresses common doubts and misconceptions. As trainers, you can encourage learners to think the answers and then go back to explain the concept that has not been fully understood by students. And as we can see, many of these questions are exactly what a client might ask. So it is vital for learners to master the appropriate responses. Beyond simply reviewing core concepts, this section introduces crucial data and orders of magnitude that ground theoretical knowledge in real-world situations. So, for instance, when addressing this question, will my energy bill increase if I install a heat pump? Learners can provide concrete evidence by citing the average annual savings when transitioning from a traditional gas boiler to a high-efficiency heat pump system. Or, for example, with this other question, will a heat pump help to reduce my home's carbon footprint? They can provide specific data on carbon emission reductions, and this allows learners to quantify the environmental benefits. which is a doubt that clients may have. Equipping learners with these specific metrics not only builds their technical authority, but also empowers them to handle common client objections with data-driven confidence. And we need to remind that this skill is also part of the installer-client relationship that we were talking about in lesson 1. And then the module finishes with a self-assessment quiz and practical exercises. This quiz includes 20 questions, and its purpose is to check whether learners have understood the core concepts of this module. And please remind that the quiz can be retaken, so it's advised to use it as a learning tool, discussing the mistakes and clarifying any misconceptions. So students can retake it once they have understood the mistakes they made, if they made any mistakes. And finally, we have the practical exercises, which are especially important in this module because learners can apply the calculations they explored in this lesson. The first exercise is about using the heat loss calculation formula. And as trainers, you can provide reference tables or use the online tools previously mentioned to get, for example, values such as the U value, which you will need for these calculations. You have here the whole formula. And then exercise 2 explains how to calculate the energy required to heat water with heat pump systems. You have the complete solution here, but you can also take this opportunity to explore and compare different scenarios. As trainers, you can change the number of occupants once you have completed this exercise and see what will happen. Or you can also change the water requirements per day. And it's an interesting exercise for students too. So this is everything about the module. And to put briefly together what we have covered today, first, we started more on the human side of the installation process, managing clients' expectations from the beginning and building long-term relationships with the customer. Then we analyzed site-specific technical requirements, such as optimal unit placement or hydraulic system flushing to ensure long-term operational assurance and regulatory compliance. And finally, we explore the technical aspects of heat loss calculations and radiator sizing, as well as hot water requirements, complemented with the practical exercises and the questions and answers and self-assessment quiz. This is everything on my side. And to conclude, you can also take a look at the virtual assistant app, where you can find relevant information and a practical guide to heat pumps. You can access the app by scanning the code. And thank you very much for attending this session.
Thank you very much, Irene, if I'm telling this correctly. This is also my name, but in Greek. Are there any questions regarding the course, lesson 2, or anything in regards to the project? Any comments, any questions? Tadi, you can please open your microphone, or... Yes, now we can hear you.
Yeah, while doing this client management, are we going to explain them return on investment ROI for how many years the investment can be basically the return can we get, so that is return on investments. That period we can tell them.
I'm sorry, can you repeat, please? I think there's an error with, I couldn't hear you properly.
Okay. For example, we have gone to the client and we understood the expectation of the client, and after understanding the expectation and while we are preparing our project, are we telling the client that your return on investment will be this much years or this much months, like that? Are we going to tell them?
We should, first of all, answer all of the questions that the clients may have, and we should give an honest review as the results of the site survey. But yes, everything should be clear for the clients.
Okay, so that is needs to be clarified with the client. Okay, thank you.
Thank you.
Any other questions or comments? I think not. So I think we are officially concluding session 2 of the Pump Up Training Seminars.
Another question I have.
Yes,
That
of course.
this study material you are sending to us?
For the next session, you mean?
No, these because in the session 1, basically module 1, I was not there.
Okay,
So,
the session 1 has been recorded and we will upload it on the YouTube channel of the project as soon as all the sessions are completed. So you can follow the project on LinkedIn or in Facebook. We have those 2 social media channels and you will get every update there. But yes, every session is recorded and will be uploaded there, and all of the news of the project will be on LinkedIn or on Facebook. So you can follow us there to be up to date with everything. Now, regarding the session number 3, it's gonna be on Monday, 11th of May, same time. So we are again welcoming you to the next sessions, and you can either join on your own or bring your colleagues, anyone who wishes to be informed about the lessons. And as I said before, everything is updated on the social media channels if in case something changes, which I hope not. It's every Monday and Wednesday of May. And there is no problem if you can't join a session. You can join whichever you wish, and it's more convenient for you and your schedule, your program.
no, I will join all sessions. I will join all sessions. No
That's
issues.
great. That's great. And we hope to see more of you. You're very welcome to join.
Okay. Thank you.
We thank you. So I think that's all for today, and see you on Monday.
Yes. Yes.
Thank you very much, and thank you, Irene, for the session.
Thank you,
Thank
Irene.
you.
Bye.